right, so far we've studied the integrals and derivatives now of both the natural log function and e to the x. Well, our base doesn't always have to be e, so what do you do when the base is not e? So that's what we're going to be investigating next. At the end of this lesson, you'll be able to find the derivative of a function with a base other than e. All right. So we are going to have a base of a. Remember when we did our first exploration, some people had the base of 5, some people had a base of 10, of 2. So we're talking about like 2 to the x, 3 to the x, log base 4 of x, all those different things. So how can you take the derivative if you have something that looks like that? Right? Basically, the derivative is going to be very similar to my e's and my ln's. They're just going to be one little step further. If you recall, this one says y equals a to the u. When we took the derivative, if we had e to the u, if you recall our derivative was just e to the u du, this basically is going to be the same thing. The derivative of a to the u is just going to be a to the u du, but we actually are going to have an extra step on this one, that we have to finish it by actually multiplying by the natural log of our base, so times the natural log of a. I'm just going to show you one thing. We actually could have done it on this one as well, because the natural log of e was just 1. So that was an unneeded step in our problem. That's why we were just able to do e to the u. Okay, so that's the formula. All right, the other one is the log base a of u. If you recall, if we had ln of u, when we took the derivative, we got du over u. Well, if I have a log to a different base, I'm going to do that exact same thing. It's still going to be du over u, but again, we're going to add in that extra step of doing the natural log of a. Notice, even though this is a log, when I do my multiplying, it's going to be the natural log of a. So, and we could have done that same thing on here, but our natural log would have been e, and that would have just been 1. So if you know these formulas, the e and the ln formula, these are just one step different. So let's see if we can do some examples to get there. Alrighty, it says to find the derivative f of x equals 3 to the 5x. So notice this one, this is my a, this is my u. So I have a to the u. And remembering our formulas, the derivative of a to the u is just a to the u, so it'll still be 3 to the 5x, times du, so times the derivative of 5x, which is 5, and then times ln a, so times ln 3. And I'd probably rewrite this, maybe it will look a little bit better if I did 5 ln 3 and then 3 to the 5x. I don't know if that looks any cleaner, maybe a little bit, but that's how I'll write it. All right, next one. Find the derivative of log base 10 of x squared minus 1 all over x. Okay, the first thing that we want to do, just like what we did on the previous problems on the ln, we don't want there to be a division sign. So we're actually going to use our properties to rewrite this first. This would actually be log base 10 of x squared minus 1 minus log base 10 of x. And we really wouldn't, I guess, have to write the 10 because a log is implied base 10, but oh well. All right, so we've subtracted them, and then now we are set. So now we can take the derivative. Okay, the first thing that we want to identify, this is going to be our a, this will be our u, this will be our a, this will be our u. Okay, just like the derivative of the natural log is du over u, this one is also du over u, so we're going to do du, so it will be 2x over u over x squared minus 1 times ln a, so times ln 10. And then minus, same thing, du over u, so it will be 1 over x times the natural log of a, so times the natural log of 10. Okay, so that's pretty much it. The one thing that I'm going to do to clean it up, I do notice that they both have that natural log of 10, so I'm going to factor it out. So I'm going to factor out 1 over the natural log of 10 because the natural log of 10 is on the bottom. And then let's just look at what we have left. Then we're going to have 2x over x squared minus 1 minus 1 over x. And that's how we can actually leave our problem, and we should be good to go on that. All right, example 3. We have f of t equals 3 to the 2t divided by t. I do notice up top we are going to use the a to the u derivative. On the bottom we just have a t. This is actually a problem, two functions being divided by each other. So I actually on this one have to use the quotient rule. So we have to be careful. Just because we learn new rules, our old rules don't just fall out the wayside. We've got to actually use them. So I'm going to let the top be f and the bottom be g. To get f prime, I do notice that this is an a to the u problem. The derivative of a to the u is just a to the u. and then times du, the derivative of 2t is 2, and then times ln a, so times ln 3. Okay, so I think I'll rewrite this again as 2 ln 3, and then times 3 to the 2t. Alrighty, my g prime will equal, the derivative of t is just 1, so that was good. Okay, so our derivative will equal f prime times g. So 2 ln 3 times 3 to the 2t times t minus f times g prime, so 3 to the 2t times 1, all over g squared, so all over t squared. Okay, the only thing that I'm going to do to clean this one up is I do notice up top there is a 3 to the 2t in both parts, so let's just factor that out. 3 to the 2t, then I'll have 2 ln 3. I'm going to actually put 2t ln 3. I don't want people to think the t is connected to the 3 because it's not. So 2t ln 3 minus 1 all over t squared, and then that would be my answer. That's as far as I can go. Alrighty, let's try one more. After t years, the value of a car purchased for $20,000 is given by the formula v equals 20,000 times 3/4 to the t. Find the rate of change of v with respect to t when t equals 1. So if it's asking me for the rate of change of v, I know I'm looking for v prime, and I'm looking for it at 1. Now on this one, what's kind of nice is I'm going to let this be a calculator problem. So as long as I know I need to take the derivative at a certain spot, we can go ahead and use the Math 8 button to get there. I will use it just in case you would like to watch me use it, so get out your calculator if you would like to watch me do that. Alright, so let's type that function, and we've got 20,000 times 3/4 raised to the x. Let's press enter. I'm going to quit here a second. And then we'll do Math 8. So Math 8. And I'm going to use Y1. If you've got your new fancy calculators, then you can just go ahead and do that the new way, but I've got to go do it this old way here. Find Y1. And then comma. We would like to find this derivative with respect to x, and then we would like to find the derivative at 1. So if we do that, press enter, and notice I get negative $4,315.23. So that would be the value. So let's go back here. So my answer is going to be negative $4,315.23. So the rate of change is negative because the car is losing value. So hopefully now you can find the derivative of functions that have a base other than e.